When you first open Stata, Stata is a general use statistical package. It includes features for data management, so you can import data from different sources, Excel or other SPSS, SAS, things like that, or even from across the web. And then you can clean your data, you can manage your data, you can merge files and append files, create new variables. All the usual things you would expect to do with data management can be done within Stata. And then there are extensive graphics capabilities, and we'll barely be able to scratch the surface of that today, but there are some really cool websites out there where people do some amazing things with Stata graphics. And then, of course, there's the statistics features, which are quite extensive. There are, one of the questions I often get, and I'll just go ahead and tackle it now instead of waiting for the question, is there are no modules. It sounds like a lot of you use SPSS, and so you purchase base SPSS, and if you want Amos, you have to get that separately. There's none of that in Stata. When you open it, everything is there and working. There are no add-ons. Structural equation modeling is just in there. Multiple imputation is just in there. Bayesian statistics, all of the GIS stuff for doing maps, all of those things are just in there. So when you get it, everything is there, and you're not going to have to go track down other features somewhere else later. There are lots of user-written commands, though, so people are always adding new features. We call them user-written commands, and there's a repository out on the web where a lot of people post them, and other people put them in GitHub repositories. So much like other software, you can add on new commands and things like that. Anyway, by the way, if you have questions along the way, please just unmute and jump in anytime. So when you first open Stata, this is what the interface looks like. I have a data set already open in it, but we'll go through and talk about these windows here shortly. There is a menu system. So there's a point and click style interface where you can go to, say, statistics and go find the features you're looking for, and then open a dialog box and point and click your way through the options. And then when you click submit or OK, it will actually generate the command syntax for you. And if you want, you can copy and paste that over into a batch file. We call them do files. And then you can run them later on. And I'll actually show you this stuff here shortly. Again, there are tons and tons of features in here for importing and managing your data, graphics. All these statistical features are already built in. Like I said, there are no add-ons or modules you have to find later. There are dialog boxes for every command in Stata. I can't think of any command that does not have a dialog box. And so again, you can point and click your way through. Most of them are, at least the regression dialog boxes, are arranged much like this. They'll have a model tab where you fill in the dependent variable and the independent variables. And depending on the type of model, the stuff below it may be more sophisticated. And then there's a by if in tab that allows you to restrict your sample. Weights, if you have weighted data. I'm going to go through and show you this in person here in a moment, so I don't want to spend too much time on it here in the slides. There's a data editor. We'll take a look at that here in a moment. There's also a do file editor, so we have a built-in batch file editor, and it has command highlighting for Stata. It also has command highlighting for Python, because you can run Python from within Stata. So a lot of people, you can just be typing your Stata code, and then if you want to do something from Python, as long as you have Stata set up to work with Python, you have to tell it where the executable is. You can then type Python : and then start typing Python commands. And when you're done using Python, right there in Stata, you just type end, and it goes back into Stata mode, and then you go back to typing your Stata commands. And you can call Python scripts and things like that. There are help files there's a help file for every command in Stata, and that's meant to be like the get you up and running quickly kind of help file. It has examples, it has a basic description of the syntax. But if you want all the information about a command, that's in the PDF documentation, and that's included with Stata. When you install Stata, this is installed locally on your machine. It's also available freely on the web, so you can just Google Stata manuals, and they're all just sitting there on our website, and you can read them there. Here, you can go through and find extensive descriptions of the syntax and the options. One of my favorite sections is the remarks and examples section, because it actually shows you worked examples with the command, and we have example data sets that work with each of the commands. And so you can actually do the examples and it will interpret the result. It will tell you about the assumptions of the model, how you formulate the syntax, then how you interpret the results after you've run it, and maybe how to do some other specialty things after. The other cool thing in the PDF documentation is the methods and formulas, and that's where we show you the actual math that's being used. Some software, I won't name names, is kind of not real transparent about the actual math that's going on under the hood, but we actually have a methods and formulas section in the manuals that tells you exactly what we're doing and gives you references to the papers as to the methodology. Now, something you may or may not ever use, but just so you know that it's in there, Stata, by the way, Stata runs on Mac, Windows, and Linux. And the way we're able to do that is that Stata itself is built on those three platforms using C. So the software itself, Stata, is written in C. But then on top of that, we have our own matrix programming language called Meta. Meta is very much like C. The syntax looks and feels a lot like C or C++ if you've ever used these languages. And this is what most of Stata's I'm blanking on the word, estimators or statistical estimators and graphics and things like that are written in. It's an object-oriented language. It basically looks and feels like C++. It's object-oriented. It has loads of mathematical and statistical functions. It supports real and complex numbers, has lots of solvers and inverters. You can do low-level file input and output. So if you have machines that spit out, files in strange formats, you can actually read those in at a low-level file, not like importing an SPSS file, but reading low-level files. You can do that with Meta. And one of the nicest things is that it interfaces directly with Stata. So one of the things you can do is if you're using Stata and you want to write your own estimation commands, you can actually take data from Stata, drop it or convert it down into Meta matrices, and then do all kinds of calculations with the matrices, and then send the results back up into Stata. So it talks to Stata or interfaces seamlessly with Stata. And what makes it so fast is that it's compiled. You actually compile your Meta code, which makes it run very fast. So you can kind of imagine this like having C++ built into Stata for doing further development, but it's called Meta and has some slight differences from C++. Now, the other thing we added in, I believe it was Stata 15 or 16, is the ability to run Python from within Stata. So Python's become really popular for a lot of machine learning tasks and more advanced data management activities, things like using APIs to grab data from around the web. So anyway, Python, if you're not familiar with it, is a modern machine learning. It's a modern language used for machine learning and doing three-dimensional graphics and animations. It's really handy for doing API data interfaces and web scraping and things like that. So again, you can run Python either as just type commands, or you can run Python scripts. So if you already have existing Python scripts that you need to integrate into your workflow, you can run those scripts from within Stata, and you can pass data from Stata into Python data frames, do whatever you need to do with your script, and then pass it back, the results back from Python into Stata. So they interact really nicely. And then you can even incorporate scripts into your Python scripts into your own Stata commands if you create your own Stata commands. And I know we're talking about really advanced things right now, but just so you're aware of what's in there and what's available. So what I have next is just a series of the kinds of data analyses that you're likely to do. But what I want to do is jump out for just a minute from the slides and actually show you Stata. And then if you have questions, we can do that. Well, I can answer questions, and then if you like, we can come back and I'll walk you through some little simple data analysis examples. Okay, so I'm going to stop sharing this and move to Stata. Any questions while I'm switching over to Stata? Okay. All right, so you should be able to see Stata on your screen now. Should be mostly a big open white screen. Is that what you're seeing? Okay, great. So this is Stata 17. When you first open Stata, this is actually what it will look like. Yours will actually have some writing in the middle of the screen in the results window, but I have mine set to blank all that out when I open it. So this giant white space in the middle is the results window. And anytime you interact with Stata, that's where you're going to see the results, whether you're using the command interface, command window, or the do file interface, the batch files, or the point and click interface. All of those results will show up here in this results window. Right below the results window is a command window. And here I can just type stuff, like I could type display. I'm horrible at typing in front of an audience. So hello world. So if I just type that command and press enter, the command will show up in the window. Let me make the font a little bigger so you can read this. There we go. Is that a little easier to read? Can you read the output? Okay. Yeah, so it'll just, you can type a command in the command window. It will echo that command in the results window and then show you the results of whatever it is that you want to do. I could also open, for example, an example data set. So I'm going to type sysuse auto. This is a data set that we use that's included with Stata. And I've typed sysuse because it's a system data set that's just sitting there. You can use it anytime. And auto is the name of the data set. So that opens this data set, and we'll take a look at that, the variables in that in just a moment. So that's the command window here at the very bottom. On the top left, there is a history window that keeps a running tab or running list of all of the commands that you type, either in the command window or in the using the dialog box or whatever. And so those commands here, I can make these fonts bigger as well. I should have done this earlier. It'll keep this running log of all the commands. And then if I want, I can go back and click on those commands in the history window, and it will send them back to the command window. So let's say that I make a typo, which I do all the time. In fact, I'm surprised I didn't earlier. See, I misspelled display, so it gives me an error. Rather than retyping the entire command, I can just click on that command in the history window, and that sends it back to the command window, and then I can edit that. So display. Another thing that I can do is I can hit the page up button. If I'm in the command window, I can hit page up, and that will scroll up and down through the history window. So it's a quick and easy way if I've made some typos to just correct those. Now, at the top right, there's a window here in the top right that's called the variables window. I'm going to make this font bigger as well. And this displays the variables that are open in the current data set. There are lots and lots of things you can do with the variables window. I have to confess, I don't really use those features much, and so I'm not familiar with them. There's a little filter bar here, and you can filter things in different ways. If you have hundreds or thousands of variables, you can search for them here in this little search window at the top, like make. Oops, I mistyped it. So you can search for variables in the window and things like that. By default, it's going to show you the name of the variable and the variable label, and you can scroll up and down through those if you have lots of them in there. Then right below the variables window is the properties window. And so what I can do is I can select a variable in the variables window, and it will show me the properties of that variable in the properties window. So for instance, I'm going to click this little unlock bar to make it a little easier to read. It shows me the name of the variable label. So the variable weight is actually weight measured in pounds. So it tells me that. It tells me things like the storage type. This is stored as an integer as opposed to a floating point number or a double precision number. I can format the display of the number right here. I can change that in the properties window as well. So if I want to change this, maybe it's a date with time in it, or a daily date, or some other kind of number, I can custom format that using the format option here. And I can also define value labels for categorical variables, so I can go through and create those sorts of things here. I can even add notes to my variables. So if I want to add a note, something that I don't want to put in the variable label, but maybe I'm working with a team and I want to put some note in there that says, hey, all the values above a certain level were set to missing, or something like that. I could just put notes for my colleagues in here, and then they can read those notes later on. And that's saved with the data set so that when somebody else opens the data set, they can see those notes. You can do the same thing with a data set. So you can change file names and labels and add notes to the data set, things like that here at the bottom. So that's what you can do with the properties window. It is by default locked, so you can view it but not change it. But if you click this little padlock icon, it unlocks it, and you can actually edit those things live right there in that window. Okay. So that's the main interface when you first open Stata. I want to show you one other quick thing before we go to the menu system, the spreadsheet style data editor. So can you see a thing that looks like a spreadsheet now? Did that open, or do I need to? Okay. I'm never sure with Zoom what shows in the window and what doesn't. So if you click on the data editor, it shows you your data in a spreadsheet style interface. And notice that it continues with the variables window and the properties window on the right. That's built into the data editor as well. You can open the data editor in edit mode, which I am now, or browse mode. And if you do that, you can view the data, but you can't change it. And that, if your cat runs across the keyboard or something, you don't have to worry about messing up your data. You can open this in edit mode. There's an icon next to it that says data editor, and then it says edit in parentheses. Now it's live. You can actually go in here and edit this just like a spreadsheet if you wanted to. Typically in research, we edit these with batch files and make notes and things. But if you were just doing a class assignment, you can actually just point and click and select a cell and change the data if you like, just like any other spreadsheet. Okay. So before I dive into the menu system, let me pause here. Are there any questions so far? Okay. So let me start up here at the top left with file. Under file, that has the usual suspects, things like open, save, view, things like that. But the things you may be more interested in are logs. So if you want to send all of your output to a log file, you can do that. And so I could go under log and select begin. And then I could just go through and start saving a log of all of my output. I can also import data from under the file menu. So if I wanted to import an Excel spreadsheet, I could click that, and this allows me to click browse and then go open. It'll let you preview the data in this little preview window down at the bottom when you select a file. You can select a particular cell range or a worksheet or all kinds of things like that. Same thing with text files. So you can import good old-fashioned ASCII text files, SPSS data, SAS data. If you have text data in some sort of a fixed format with fixed columns and things like that, those sorts of old-fashioned files, you can grab that. SAS transport files, the SAS export, that's a popular way of storing data and distributing it on the internet, for example. It's a little different than a SAS data file. It's called a SAS transport file. So anyway, you can import and export those directly. I doubt many of you are using the FRED data, but FRED is the Federal Reserve Economic Data. Stata is very, very popular among economists and econometricians, and so we've built in the ability to query the Federal Reserve System, their data. It's called FRED. You have to have a FRED key to get into this, but if you do, from within Stata, you can actually query the Federal Reserve economic data. There's a big dialog box and all of that. I don't have an account because I'm not an economist, but there's another company that's involved in economic data called Haver Analytics, and if you have those sorts of data, you can query those and pull them straight into Stata as well. If you're familiar with ODBC, that stands for Open Database Connectivity. So if you have data that's stored in any kind of a database, like a real professional database, DBase or Oracle or things like that, you can actually run what's called an ODBC pipe into your database. So your data are actually stored you could store it in a password protected database, but have access to it through an ODBC pipe from within Stata. A lot of pharmaceutical folks and people that deal with very sensitive data will use this so that they don't actually store their data in Stata. They store it in a password protected database and then just access that data in Stata through an ODBC connection. So lots of ways to import and export your data, get it in and out of Stata. Now, data, let's take a quick look at the data menu here. You can do the usual things. If you're familiar with SPSS or SAS or other software, you can do the same sorts of activities. So you can describe your data. You can say, make a list of the variables and their variable names and how they're stored and things like that. You can summarize data and get, means and medians and modes and all sorts of things like that. You can also append data. So if you have data from multiple years and you need to append multiple files together, like stack them on top of each other, you can do that. If you need to merge data, I always think of merging as sort of side by side, where I have data on the same people, but different variables, and you need to merge those into one file. You can do all those sorts of things. In Stata 15 or 16, I forget now. We added what are called data frames, which gives you the ability to have multiple data sets open simultaneously in Stata. And you can link frames so that you can have multiple data sets open and then have them linked and use variables from across data sets simultaneously. You can define your own matrices. So if you want to input a matrix by hand, for example, here's a little dialog box. So you give your matrix a name, you tell it the number of rows and columns, type the numbers in, and now you have a matrix. And then you can do matrix calculations with those sorts of things. What else? I don't know if any of you work with ICD codes, International Classification of Diseases, but that's in the medical world, that's sort of how they document their various diagnoses. Different diagnoses have different diagnostic codes. And those codes are actually built into Stata, so you don't have to type all their names. So if you have a data set that has all the codes, you don't want to have to type in all the value labels for all of those different codes and what they mean. They're already built into Stata, so you don't have to mess with that. There's a hand calculator built in. There are ways that you can set up what are called business calendars. So if you're dealing with time series data, for example, and you have lags, you want to do lag 1. If you're on Monday, lag 1 for a business day, the lag 1 back from Monday is Friday, not Sunday. And so you can define holidays and other things. We call them business calendars. Anyway, it's handy for if you're working with things like time series data and you're dealing with lags and leads that go across weekends or holidays and things like that. So yeah, data management, whatever you need to do, it's almost a sure certainty you can do that within Stata. Graphics. Now, graphics is a little interesting. We've set it up in such a way, it does so many things. How do you organize it? Some graphs are so popular that we put them right off the main branch here under graphics. So like bar charts, if you want to create a bar chart, you just select that and it will open a dialog box. And you can tell it whether you want to do a graph of summary statistics or a graph of frequencies within categories or percents within categories or actual data or whatever you want to do. You can make them horizontal or vertical. You can do various statistics of different variables and create bar charts from those and select different categories. So anyway, bar charts makes it quick and easy to go straight to bar charts and do that easily. Same thing with stuff like pie charts or histograms or box plots. These are so common that they're right here off the top of the menu. Other things that are a little bit more sophisticated are grouped together below in branches. So for instance, distributional plots, if you want to look at symmetry plots or quantile plots, normal quantile plots, QQ plots, ladder of powers, things like that. Those are organized under distributional plots. Smoothing and densities, so like LOS and local polynomial smoothers, kernel density estimation, those things are grouped together. Regression diagnostic plots. So you fit a regression model and you want to look at a residual versus fitted plot or a residual versus predictor or a component plus those kinds of diagnostic plots after a regression model, they're grouped together. Time series graphs, survival analysis, multivariate analysis, scree plots, things like that. So they're all grouped together below here in little branches off the main menu. But the main workhorse for Stata graphics is the two-way command. So this looks like, and let me just type CLS to clear out the screen here, make it easier to see. Two-way, the dialog box looks deceptively simple. This area where it says plot definitions, what you can do is create a plot, and then you can overlay other plots on top of plots, and you can control the opacity of various plots. And so what I can do then is I can create, maybe I just want to create a simple scatter plot. So I would select basic scatter plots, scatter, and then I could select something like weight, maybe the weight of a car and the miles per gallon of a car, and then click accept and submit. And the first time you run it, can you see the graph? Does that show up in the window? Okay, good. I'm still not used to what shows up in Zoom and what doesn't. So I can create that graph, but then if I wanted to overlay something on top of that, I go back to the two-way dialog box, select create, and then maybe I want to put a fit plot on top of that. So maybe I'd like to add a linear prediction or maybe a linear prediction with a confidence interval. So again, I would select the weight of the car and the miles per gallon of the car. and click accept here. And then I'm going to click submit. And now that's going to overlay the regression line on top of the scatter plot along with a confidence band. And I could do a quadratic fit plot or whatever. And I'm not going to mess with it here, but I could change the opacity of this, of the confidence band, so that you could see the dots behind it, or I could move one in front of the other so I can overlay. I don't know if there's a limit to how many plots you can overlay on top of each other. But anyway, using this overlay, the ability to stack these graphs or overlay them on top of each other, you can create some really sophisticated graphs. And then if you go back under the graphics menu, you can actually create dashboards of these things. So you can select multiple graphs and then put them, one in the left corner, one in the right corner, or arrange them however you like. So it's really easy to create overlaid graphs and then do these dashboard style graphics. Anyway, so you can create all kinds of things in here. So basic plots, they're the usual things: scatter, line, connected, area, bar, spikes. Range plots, if you want to graph some sort of a range, and you can put spikes or caps or whatever you want on those. Contour plots, I'm a big fan of using contour plots for showing interactions of continuous by continuous interactions in regression models. Contour plots are a fun way to display those. I just mentioned fit plots a few minutes ago, so you can do fractional polynomials or quadratic predictions and put confidence intervals around those fractional polynomials, whatever. Immediate plots are fun because you can actually use Stata's graphics window or image sort of like graph paper. So you can just draw a line from this point to that point, or draw a function or whatever you want. And then the advanced plots, there are all kinds of time series plots: median, band, splines, low S, kernel density, local polynomial smooth lines, with or without confidence intervals. You can graph functions or paired coordinates. So all different kinds of graphics types. And then again, as I said, you can overlay these things on top of each other and put them next to each other and create all kinds of fancy graphics. So that's graphics. Any questions up to here? Okay, so let's take a quick look at the statistics menu. This is a long menu because there's a lot of stuff in here now. At the very top section, we've organized the branches by dependent variable type. So the very first thing are summary statistics. So if you just want to do means or proportions or whatever, or some tables, that's the very first thing. But below that, the branches are organized by the type of dependent variable. So linear models, if you have continuous outcomes, you could look under linear models and related and fit linear regression models, or ANOVA, MANOVA, censored regression, truncated regression, hurdle regression, all kinds of, fractional polynomials, Bayesian models, finite mixture models, lasso, all of that stuff for continuous outcomes is grouped under that branch off the main menu. If you have binary outcomes, that's all grouped together. So you have logistic regression and probit regression and complementary log-log or exact logistic regression and all kinds of things there. And the Bayesian stuff is usually near the bottom. Ordinal outcomes, categorical outcomes, count outcomes, fractional outcomes, generalized linear models, as well as choice models. I think that's something we added in Stata 15 or 16 as well. And then below that, we've organized things by topic area. So for instance, time series, all the univariate time series features are grouped together under this branch. Multivariate time series is below that. Spatial autoregressive models. So if you have spatial data and you want to fit spatial autoregressive models, that's right here off the main menu. Longitudinal panel data, multi-level mixed effects models. So you can fit all different kinds of multi-level models for continuous outcomes or binary outcomes or ordinal outcomes, whatever you want. Excuse me. Survival analysis is grouped here. Epidemiology and related. Endogenous covariates, this comes up a lot for economists, and so we have all the stuff that deals with endogenous covariates grouped together. Sample selection models like Heckman selection style models, those are grouped together. The treatment effects models, this is how we refer to causal inference models. We refer to them as treatment effects, and we have these subgrouped then by continuous outcomes, binary outcomes, count outcomes. So things like inverse probability weighting, propensity score matching, nearest neighbor matching, those sorts of things, the doubly robust estimators, those are grouped together under treatment effects. So that's all the causal inference stuff. Right next door is structural equation modeling, or SEM. And so there's a built-in structural equation modeling builder that allows you to draw your models. And so I could come under here just really quickly and use this little wizard to create a little measurement model here. This doesn't make any sense. I'm just doing it to show you that it can be done. So I could use this to draw a structural equation model, and then when I'm ready to estimate it, I just click the estimate button and then select my estimation options. Do I want to use maximum likelihood or FIML for full information maximum likelihood, things like that. So that's all available under here, and you can draw the model and it will generate the syntax for you. Below that is latent class analysis, which is related to structural equation modeling, finite mixture models, which is a more generalized version of latent class analysis. LCA is actually a special case of finite mixture models. Item response theory, we've made this super simple. I don't know if any of you work with item response theory models, but you can come in here and just click your way down this little interface. And if you have binary, correct or incorrect items, you can fit 1PL, 2PL, 3PL models. If you have ordered items, you can fit graded response models, partial credit models, all kinds of things, including hybrid models that are mixtures of those. And you can test for differential item functioning. So if you work with those sorts of psychometric type data, that we've made it really easy to do that. Multivariate analysis, we have the usual suspects in here: MANOVA, cluster analysis, factor analysis, multidimensional scaling, and things like that. We've made survey data, working with survey data, very, very easy in Stata. So you basically tell Stata about the structure of your data. So you can go into the survey set dialog box here, tell it the number of sampling stages, tell it the primary sampling units at each stage, and any strata or finite population correction factors or sampling weights, and tell Stata about all of that information in this one dialog box or command. And then for the rest of the commands in Stata, you can just type SVY : in front of the command, and it adjusts for all the complex survey design. And if you like, I can show you an example of that here in a moment. I'm not entirely sure what you guys want to see, so I'm just kind of rushing through all of the features first, and then I'm going to stop talking at some point and let you guide me through whatever you want to see. Lasso has become very popular. It's a machine learning style variable selection technique. And so you can do lasso with an elastic net and things like that, square root lasso, for a variety of different models: continuous outcomes, binary outcomes, count outcomes. Meta-analysis. We've made meta-analysis really easy as well, with a big control panel that walks you through the process of doing your meta-analysis, and you can do your various plots and things like that. Where did I leave off? Multiple imputation. So if you have missing data and you are able to do multiple imputation, again, we have one of these control panels that walks you through the steps of imputing your data. And once you've set up your multiple imputation model, then you can use this with just about any Stata command. So anyway, multiple imputation is really simple to do. Non-parametric statistics, it's kind of old school, but a lot of people still use these methods, as well as some newer things. There are newer kinds of non-parametric analyses in there. Exact statistics, so if you need to do exact logistic or exact Poisson regression, that's built in. Resampling, if you want to bootstrap your standard errors or use jackknife or permutation tests, those sorts of things, that's built in and easy to do. Power and sample size calculations. We added this, I believe, in Stata 15 or 16, and it's been growing ever since. So we have an extensive collection of power calculators that are built in here. So you can just click these things, maybe a confidence interval for one mean, and you want to do a sample size calculation for that. So you can, or you can do the confidence interval width, or the probability of a confidence interval width, or power, or sample size, or minimum detectable effect size. So that stuff's all built in here. Bayesian statistics. I almost forgot. We've made Bayesian statistics really, really simple. So in fact, it's easier to show you. I a quick example of a regression model and show you how easy it is to do this. So I'm going to go to Statistics, Linear Models, and Related, and I'm going to select Linear Regression. So I'm going to select as the dependent variable miles per gallon. This is that little auto data set. And I might want to see if the weight of the car is related to the miles per gallon. So I can do that. Oops, I need to make the results window a little wider so it doesn't make a mess. I made the font bigger. How do I make this window wider? Here we go. Ah, that looks better. So here I see my output from my regression model, and it's showing me my usual things you would expect in the output, the ANOVA table at the top, an F statistic, a p-value of adjusted R squared, the coefficients. If I wanted the Bayesian equivalent of this, I can simply put Bayes colon in front of that command. So type Bayes colon, and what it's going to do is run the Bayesian equivalent of that regression model. So rather than reporting coefficients and standard errors, it's going to report the mean of the posterior distribution, the standard deviation of the posterior distribution, 95% credible interval instead of a confidence interval. So we've made it really, really easy to fit Bayesian models in Stata. Now, how would you do that if you just type Bayes colon? How do you know what the priors are and things like that? We've pre-selected priors for you for these various types of models for each command. And so the prior, well, we won't go down the Bayesian road, but you do have the ability to change the priors. You can completely customize your Bayesian models. It's just that the starting place is a lot easier because you start by just typing Bayes colon. And if you want to add options, you add that between the word Bayes and the colon. So then you could customize priors or customize the MCMC chain and things like that. So let me show you a couple other things just really quickly, and then I'm going to stop and take questions. Let's say that I wanted to fit a logistic regression command, and this is going to be really goofy, but for foreign. So foreign cars, is the car a foreign car or a domestic car? And maybe I want to predict that by the weight of the car and what else? Maybe rep 78, that's the car's repair reputation. What I'm going to do here is use what we call factor variable notation to write my model. So I'm going to fit this model where foreign is my binary dependent variable and weight is a continuous predictor, and its reputation, its repair reputation in 1978, which is a categorical variable, are predictors. And I want to see the main effect of weight, the main effect of rep 78, as well as the interaction between them. So if I fit this model, I get these odds ratios out of the model. And the odds ratios are tricky enough to interpret alone. And this model already doesn't make sense. You can see some of these weird results. But where I'm going with this is that interpreting odds ratios for interaction terms are particularly tricky. And what you can do is after you fit models, you can in Stata type margins, and then I want to see rep 78 at, this is not a very good example, weight equals maybe 2,000 pounds in increments of 500 to 4,000 pounds. And I've made a mistake. Oh, I think I don't need the double equals here. Oh, wait. That's what I needed, I think. Yeah, there we go. So what this does is it calculates the expected or the marginal miles per gallon. Excuse me, not miles per gallon. This is foreign and domestic. The probability that the car is a foreign car at each level of the reputation variable and each weight of the car. So I've done the weight of the car at 2,000 pounds, 2,500 pounds, 3,000 pounds, and so forth for each category of rep 78. And it gives me that predicted probability that it's a foreign car. Well, this may or may not be useful information to you, but what I can do after is type margins plot, and it will actually plot the results from that model. This is a terrible example. I should have opened a different data set. But what it's going to do is show me the weight of the car on the horizontal axis, the probability that it's a foreign car on the vertical axis, and then it'll show me a line from this model for each category of rep 78. It's only working for categories 3, 4, and 5 because it's a sparse data set. Again, it's a horrible example, but the idea is that it's very easy to fit a model, calculate marginal predictions from the model, and then create a graph or visualize the results of that model. I can do a better example with a different data set if you'd like to see that again. Two last things. If you want to get to the help files, you can go under back to the dialog box and click this little question mark at the bottom of any dialog box, and that will open the help file. Whoops, why is this not moving? That will open the help file for a particular command, and it'll show you the descriptions of the various options. And if you really want to see the details, you can click View Complete PDF Manual, and that one will open. And you may not be able to see this because it opens in Adobe Acrobat, but that will open the PDF documentation in Adobe Acrobat, and that's where you see all the remarks and examples and the methods and formulas and things like that. So I'm going to stop talking. I feel like I've been doing a lot of talking, and I want to give you guys time to ask questions and me show you things that you're interested in. So any questions?